So in this video today, we're going to go over the Unit 5B test review. First question up here says find question mark. So the first thing we're going to have to do to find this is we're going to have to subtract the two arcs we have from 360 to find that arc out there. Okay, so we're going to do 360 minus our 88 minus our 94. That's going to give us that arc on the outside, which was 178 degrees. Okay, so I'm going to go ahead and put that out there. That's 178. Now remember, we do our big arc inside the angle minus the little arc inside the angle, and that divide that by 2. So we're going to do our 178, that's our big arc out here. We're going to subtract the little arc right here, 94, from it. And we're going to divide that by 2. Okay, so when I did that, I got that this was 84 divided by 2. So our question mark is going to be, that's our angle rate, is going to be 42 degrees. All right, this next one says, given that the measure of angle WXY is this angle right here, WXY. You'll see the arc WY closes it in. Then we have angle WZY. Same arc. Y'all see that? That means the angles are equal, okay? So we're going to set them equal to each other. So that's going to be 3x plus 4 equals 4x minus 7. We're going to subtract 3x from both sides. So that now our 3 x's are gone from there, and we're left with an x over here. We're going to add 7 to both sides. So that means x is equal to 11. Now, it didn't ask us for x. It asked us to find arc WY, which was this arc down here. Now, remember, those two angles we just talked about, when we multiply them by 2, that's how we get the arc, okay? So what we're going to do is we're going to take this 11 and we're going to plug it in for one of our angles. 3 times 11, that's 33 plus 4. That's 37 degrees. Now, I could have put it in the other one, and I might want to just to double check my work. 4 times 11, that's 44. Minus 7 is also 37 degrees. Now, that's the angles, right? Didn't ask us for the angle, asked us for the arc. So we're going to take our 37 and we're going to multiply it times 2. And that's going to give us 74 degrees. And that is our answer for our arc, right? Because remember, our arc is twice the angle. All right, so our next question down here is number 3. It says find arc JM. So it's asking us to find this arc down here. Well, this is what I know. When I draw a straight line from this arc to that angle through to that arc, those are the things that have a relationship, right? So what I want to do is, because I need 2 of 3 to find the answer, okay? So I really want to find this angle or this one, and they would be the same, right? Because they're vertical angles. So what do we see that's going to help us do that? I see a straight line right there. Y'all see that? So what I want to do is just find this angle right there. I'm going to do 180. That's the measure of a line minus 64. And when I do that, I get 116. So I go ahead and put that back in that drawing, okay? So that 116 goes there, and it goes there, doesn't it? Because they're vertical angles. So now remember what I said. We're going to add the arc plus the arc divided by 2 to get that angle in there. So we're going to do our 83 plus our question mark divided by 2 equals our 116. So we're going to multiply both sides by 2 to get rid of that 2 in the denominator. So that gives, this now crosses out, right? So I got 83 plus question mark, and then 2 times 116 is going to be 232, right? Then we are going to subtract the 83 from both sides, right? Subtract 83 from both sides, and that means JM, which is what we're trying to find, arc JM down there, question mark, right? That's going to be equal to 149 degrees. Okay, on this next one, I notice immediately that we have a diameter, don't we? This is a diameter, which represents half the circle, doesn't it? So we know that half that circle is 180. So if we want to find this up here, what are we going to do? We're going to do 180 minus the 118. So that means that up there is going to be 62 degrees. So these two arcs add up to be 180, right? Now here's the real question. How does that arc relate to this angle whose vertex is on the circle? We have to divide that 62 by 2, don't we? So that means to find question mark down here, question mark is going to be 62 divided by 2. So question mark is going to be equal to 31 degrees. All right, so the next one says solve for the missing angle measure. Now, we got an arc out here, 257, and an arc in there. So if we want to find this inside arc, we have to subtract the outside arc from 360. So that's our first step, 360 minus 257. So when I did that, I got that this arc in here is 103. Now what you need to remember is that the big arc minus the little arc divided by 2 equals our angle. So we're going to take our 257 and we're going to subtract from it our 103. And we're going to divide that by 2. So when I did that, I got 154 divided by 2. So question mark is going to be equal to 77 degrees. Okay. And B over here, same thing, right? So again, this time we're looking for that outside arc, aren't we? So again, we're going to do our 360 minus our 132. And when we do that, whoa, what just happened? Let me see if I can turn it back. Okay, there we go. Oh, there it is. There's our question mark. Anyway, when I do that, I got 228 for this out here, right? So once again, we're doing big arc, 228, minus little arc, 132. Going to divide that by 2. When I did that, I got 96 divided by 2. So this one is going to be 48 degrees. Okay? All right, the next one says, given the arc length is 20.11 and the radius is 8 centimeters, what is the central angle? Round to the nearest degree. Notice that it says arc length here, and our formula for that is theta over 360 times pi, or actually 2 times pi times r, right? Okay, that's our formula. That's on our formula sheet. And this says that is our arc length, so we're going to do our 20.11 equals that, right? It's asking us for the central angle. That is our theta, right? And we do have our r, right? Okay, so let's go ahead and put that in there. I'm going to erase this, and we're going to put our actual r, which was said was 8, right? Okay. So how do we get rid of the 360? We multiply both sides by 360. And remember, all this stuff's going to be on the top, right? So we're going to multiply both sides by 360 right here to get rid of it. So now it's gone, okay? And so when I did that, I got 7,239.6, and that's going to be equal to what? 2 times 8 is 16, so this is going to be 16 pi times theta. So we're going to divide both sides by 16 pi. Right now, remember, I said when you do this to put it in parentheses, because otherwise it's dividing by the 16 and then multiplying by the pi. So I'm dividing both of these by 16 pi, or you can just divide by 16 and then divide by pi. Either way, theta here, which is our central angle, is going to be, I got 144 degrees, okay? All right, the next one down here says, given the sector area of a circle is 100 pi. Notice again, it says sector area. This on your formula sheet. That's going to be the formula theta over 360 times pi r squared, right? Okay, this time they give us it. It's 100 pi. And the central angle measure is 160. So we're going to go ahead and put that right there. Up here for 160, right? Remember again, this stuff's on top. The pi and the r squared, right? Divide all that, okay? So now, once again, what do you notice on both sides of the equal sign that we can cross out right now? Right, the pi's, okay? Now, what are we going to do? We're going to multiply both sides by 360. So when I did that, I got 36,000 is equal to 160 r, whoops, I forgot the 0. 160 r squared, again, so we're going to divide both sides by what next? By our 160, right? Divide by 160, divide by 160. When I did this, I got that r squared is equal to 225. Now listen again, we don't want r squared, we want r, right? So we're going to take the square root of both sides. So r is going to be equal to 15. And that is our answer for our radius. And if you aren't sure that that's what it is, plug it back in and check it, okay? All right, the next one says find the unshaded sector area round to the nearest tenth. So that means we're looking for this right here, right? So what we want to do to find that is do 360 minus our 263. So when I did that, I got 97. Okay, so that means this right here is 97 degrees. So that's going to be our theta, right? And notice our radius is going to be our 22, okay? So we're going to do theta times r squared, that's our formula, times our pi divided by 360. Okay, so we're going to do this, I'm going to show you guys how to do this. Let's see if I can get Desmos up here real quick. Maybe not. Well, never mind. It's saying round to the nearest tenth, so I'm just going to go ahead and do all of the top and divide it by 360. That's going to give us 409.7, okay? And remember, if the answer has pi in it, you're not going to multiply by pi, okay? So this is 409.7, and this is going to be inches squared, okay? Now it says find radians given degrees. Leave answers as fractions. So we're going to divide all of these by 180. In our lovely little calculators, right, that have n over d, or our Desmos calculators, which have that button you can push over on the right, right? So when I did this, I got, and we're going to add pi, 31 pi over 36 radians, right? This one is going to simplify to be 7 pi over 15 radians. This one is going to end up being 59 pi over 45 radians. And this one is going to end up being 31 pi over 20 radians. Okay, now this next one is just to flip the script, right? So this time what we're going to do is we're going to do 9 times 180 and divide it by 5. And when I did that, I got that it was 324 degrees. Again, this is 5 times 180 divided by 36. And when I did that, I got 25 degrees. This one is going to be 49 times 180 divided by 90. And this one's 98 degrees. And then this one is going to be 59 times 180 divided by 45. And this one is going to be 236 degrees. Okay? Now the next one says find the cosine and sine of the angles below. So we're looking for pi over 4. And let's see if I can get our formula sheet up here real quick again. Let me see if I can find it. There it is. Okay. Let me open this up so you guys can see what we're talking about. So I'm going to scroll down here. I'm going to open this up. Notice we've got our pi over 6 here. That's our cosine. That's our sine. Our 45 degrees, which is pi over 4, that's our cosine. That's our sine, right? Here again, 60 degrees, pi over 6, our cosine and our sine. Our x values are cosine. Our y values are sine, okay? So that's what we're looking at here. So let's go back here. And I'm going to, you know what, let's snip that and see if we can pull it in here so we can see it while we're doing it. Let me go back here. Let me see if I can snip this, y'all. Real quick. Maybe. So we're just going to snip this part right here so we could use it and bring it over here. Okay. Insert. Nope, let's paste it. There we go. Paste it. I'm going to make it a little bit littler so we can put it over here by it and we can use it to do what we're about to do. Okay. Okay. So once again, sine is our y value, right? So the sine of pi over 4, that's this value right there. So that's going to be the square. Okay, let's try this again. Wow. I don't know what it's doing, y'all. But it's not cooperating. That's okay. We got it. Good enough for this purpose, right? Okay. So again, we had our y value. So that's going to be the square root of 2 over 2. Our cosine, same thing, right? X value. Square root of 2 over 2. So there's, remember, this is our sine over here. This is our cosine over there, okay? So cosine of pi over 6, that's this one right here. Okay, so cosine, remember, is our x value. So that's going to be the square root of 3 over 2. Our sine is our y value. That's 1/2. Then we got pi over 3 right here, right? So now, again, we're doing our sine. That's going to be our square root of 3 over 2. And we're doing our cosine, which is our 1/2. So that pulls directly from our formula sheet, okay? Okay, so this next one says, what are the reference angles of the angles below? So there's a different process for each of these, okay? So when we have something that's from 270 to 360, we're going to subtract it from 360. That's going to give us 45. And remember, our only reference angles, y'all, are 30, 45, and 60, okay? So here, 120, you're going to subtract it from 180, right? So that's going to give you 60 degrees there. 210, we're going to subtract 180 from 210. So this one is, again, another 30-degree angle. Okay, 240, we're going to subtract, again, 180 from it. So this one's going to be 60 degrees. 150, we're going to subtract it from 180, right? So this one's going to be 30 degrees. And look, if you don't remember from to, right, then just subtract it and make it positive because your reference angles are always going to be positive. So 330, we're going to subtract that from 360 because it's in our fourth quadrant. So this one's going to be 30 degrees. 225, subtract 180 from it. When we do, that gives us 45 degrees here. 135, we're going to subtract it from 180. So that's going to also be 45 degrees, right? And then 300, we're going to subtract that one from 360. So this one is going to be 60 degrees, okay? So those are all our potential reference angles from the whole unit circle, okay? This next one says, what are the centers and radii of the circles? What are the equations of the circles? So the center here is, let me see if I can figure this out. So this is -5, right? Let me write it up here. -5, and so we're -5 over here, and then we're down -4, right? And our radius, let's count from the center. 1, 2, 3, 4, 5, 6. So our radius is going to be 6. So now our equation for the circle, if you remember, this is it. X minus h squared plus y minus k squared equals r squared. This is on your formula sheet again. Let me see if I can pull it up here so you guys can see it. Right there. Equation of a circle. See right there, h and k represent your center and r represents your radius, okay? So we're going to go back here again. Okay, so now we're going to write this in our equation of the circle. So that's going to be x plus 5. Remember, you change the sign when you put it in there because of that minus. Plus ry plus 4 squared. And then what are we going to do to our r? We're going to square it. And what's 6 times 6? That's 36, right? Okay, now here's our other one. Our center again, this time, let's see if we can figure out where it is. It's -1, 3, right? So this one's -1, 3, and our radius is 1, 2, right? So our radius is 2. So once again, we're putting it in that equation, remembering that this is h, and this is k, and this is r, right? So once again, I'm going to say x plus 1, we're going to change that sign, plus y minus 3, it was positive, so it becomes negative, and then 2 times 2 is 4. So there's our equation for our circle, okay? So our last two problems said, given the following equation, find the equation of the circle, then the center and radius of the circle. Okay, so we're going to group our x's and our y's, create a blank, move our constant to the other side of the equal sign, and then work, okay? So I'm going to pull all my x's, x squared plus 16x plus blank, right? Then we're going to do plus our y's, right? So now we're going to do our y's, y squared and -22y, y squared minus 22y plus blank. And remember, at this very same point, we're going to add 11 to both sides. So that's going to be equal to 11 over here, okay? So now we're going to create some parentheses. So we're going to create a parenthesis here with our x, and it's going to be squared, plus another set of parentheses right here, which is our y, and squared. And then ultimately, we're going to have equals something over here, right? Okay? So what we want to do next is divide our coefficient, just the 16 by 2, and that's going to give us plus 8, right? 16 divided by 2 is 8. Now remember, we're going to square our 8 and put it back up here in this blank, 64. Now remember, whatever we add over there, we got to add over here. Okay, so that's also 64 right there. Then we're going to, again, divide our -22 by 2, right? So that's going to give us -11 here. What is -11 squared? That's going to be 121, and we're going to add 121 to there. So when I add all that together, I get 196. Okay, now we got to figure out what the center and the radius is. So remember, when we talk about our center, we're always going to change the signs as we're pulling these values. That's my h, that's my k, right? So this is going to be -8, +11, right? And then our radius, remember, we don't just pull the value that's there. We got to take the square root of it, because that's r squared over there, right? So the square root of 196 is 14, so our radius is 14, okay? So our next one, we're going to do it similarly. I'm going to take a step down, though, so I have a little more room. So I got x squared and our -18x plus our blank, okay, plus again our y squared and our 10y, y squared plus 10y plus blank. Now remember, we're going to subtract the 6 from both sides. So that's going to give us equals a -6 over there, right? Okay, once again, we've got our x, and it's going to be squared out here, plus our y, and it's going to be squared out here, and it's going to be equal to something out here ultimately, right? So once again, dividing this by 2, so that's going to give us -9. Not -9 times -9 is 81. Don't forget to add it over here. Okay, then again, we're going to divide our 10 by 2. So that's going to give us our 5 right there. 5 times 5 is 25. Got to add it out here too. Okay, so we want to add those all together. 81 plus 25 plus 6, or excuse me, -6. Okay, so 81 plus 25 was 106. -6 is, guess what, 100, right? That's 100 right there. Okay, now remember again, when we're talking about our center, what do? We changed the sign, so that's going to be a +9 and a -5. And then when we're looking at our radius, we got to take the square root of 100, right? That's equal to the square root of 100, so that is going to be 10.